Hello and welcome to the PyPOV demo video. PyPOV is an honors project that seeks to investigate student engagement in educational programming games by identifying potentially valuable elements of games and testing their effects on student engagement in isolation. First-person puzzle and narrative elements were identified as potentially useful elements of games to foster student engagement, and as such, two game-based learning systems were designed to test the effect that these elements have in isolation. This research project was conducted by two honors students, Theo Thiessen and Cain Rademan, and was supervised by senior lecturer Gary Stewart. As technology continues to become more prevalent in every facet of our lives, the demand for computer scientists is rising rapidly globally, with a projected 22% growth rate from 2020 to 2030. Advancements in technology in the last 20 years, coupled with the high demand for computer scientists globally, has resulted in sustained growth in computer science undergraduate enrollment. However, these introductory computer science courses are subject to high dropout and failure rates. Many first-year computer science students tend to find introductory programming concepts to be challenging. There are a number of reasons and rationales as to why this is the case, but across the board, it's acknowledged that the current pedagogical methods used to teach introductory computer scientists struggle to maintain student engagement, and this lack of student engagement has a negative effect on knowledge acquisition. With the issue of student engagement in mind, this poses a problem statement. How can we best design pedagogical systems to foster student engagement in an introductory programming context? Potential solutions to this problem have been introduced, with game-based learning systems emerging as an effective means of fostering student engagement. The results of game-based learning systems in the domain of introductory computer science are largely positive, yet inconclusive and incongruent. An explanation for this high degree of variance when it comes to these results is that games, and as a result game-based learning systems, are too loosely defined to yield any pertinent research conclusions. Research indicates that the best way to evaluate the effect that game-based learning systems have on student engagement in an introductory programming context is to identify elements of games which may be effective for fostering student engagement, and to test the effect that those elements of games have on student engagement in isolation. Although this approach has shown to be effective, there's a distinct lack of research projects in this field.
We seek to address this gap in the research by investigating the effect of different game design elements on student engagement within educational games. Two studies were conducted, one by each team member. Cain's research focused on point of view and puzzle elements, and Theo's on narrative elements. The research questions for each study are as follows. For Cain's research, the question is, how does the utilization of first-person and puzzle elements affect engagement of students in an educational game designed to teach introductory programming? For Theo's research, the question is, how do game-based learning systems with strong narrative elements affect engagement of students in an introductory programming course? For each research project, an educational game utilizing the studied game elements was developed. The game focusing on first-person and puzzle elements is called Rover, and the game focusing on narrative elements is called PyStory. The games were implemented using the popular real-time development platform Unity. Since scripts in Unity are written in the language C# and players needed to write Python code, it was necessary to facilitate the execution of Python code in a C# environment. IronPython is an open-source implementation of the Python programming language, which is tightly integrated with .NET. A Python to C# interpreter for use in a Unity environment was developed using IronPython. This enabled the required functionality of students writing code to control the game world. It also enabled students to be provided with console output to allow them to debug their code in the game. Rover is an educational first-person puzzle game in which students write Python code to control a space rover and navigate an alien planet. The aim is to introduce the fundamental coding concepts of if statements and for loops in a visual, engaging way. The game utilizes point-of-view elements to draw students into the game world and engender feelings of engagement. It also utilizes puzzle elements to expose students to the problem-solving required to be an effective programmer and create a sense of challenge. In the game, students program the movements and actions of their rover, avoiding obstacles and collecting valuable crystals. The game is made up of multiple levels, consisting of 7 3D environments. The levels are scattered with various obstacles that need to be avoided, such as rocks and poisonous plants. To complete a level, students have to program the rover to get past all the obstacles. The rover's movement is constrained to a grid overlaid on the terrain. The rover can be programmed to move in a particular direction, shoot in a particular direction, and detect what objects are around it. While playing, students can switch between a first-person and top-down view to help them navigate the level. As they play, they are faced with more challenging coding levels to test their problem-solving abilities. Advanced mechanics include the addition of a line limit on the script students write, as well as levels in which the layout is semi-random.
PyStory is a game-based learning system that aims to reinforce introductory programming concepts in a way that's fun and leverages the mechanics of games to motivate student engagement. PyStory can be played in narrative or non-narrative mode. Students who play PyStory play as an astronaut who has crash-landed on a distant and unfamiliar planet. They need to navigate around the ship using WASD on their keyboard and their mouse. Unfortunately, during the crash, the onboard computer system in the rocket ship failed. And as such, the astronaut needs to navigate around to multiple scenes and write code snippets that fix the onboard computer system in each different area. There are multiple scenes that a student must interact with in order to fix their ship and escape the planet. The first of these scenes is the electricity scene, and it focuses on introducing and reinforcing the concepts of variables and typecasting. The second of these scenes is the water scene, and it involves using if statements. The third and final scene is the engine scene, and to get the engine back up and running on their ship, a student must write code snippets that involve and incorporate for loops and the 2 previous concepts. When playing the game in non-narrative mode, the player is confronted with a game-based learning system that is educational and attempts to reinforce introductory programming computer science concepts. And it has a scaling difficulty, meaning that the scenes get considerably more difficult as a student progresses. When playing PyStory in narrative mode, the player is met with all of the aforementioned elements. Alongside these elements are narrative elements, which utilize subtitles and cutscenes to convey some sort of overarching storyline to the player. This storyline attempts to induce a sense of transportation and emotional investment in the player.
For the purposes of evaluating the systems developed, user testing was conducted. Participants recruited were students at the University of Cape Town who had taken an introductory programming course. Participants played the game for around 20 to 30 minutes. Afterward, the researcher and participant had a brief, semi-structured conversation about their experience playing the game. Participants then filled out a short survey incorporating the user engagement scale. User testing for the first-person and puzzle games showed positive results, suggesting that Code Rover is effective in eliciting feelings of engagement in students. Students responded positively to the first-person and puzzle elements and linked them to their feelings of engagement. They also felt the game helped them practice basic coding concepts and would be valuable to first-year students.
The game-based learning system that isolated narrative elements saw largely positive results. Students felt that the game-based system improved their perceived sense of engagement. There was also a strong link, both qualitatively and quantitatively, between the introduction of narrative elements and an increase in student engagement. Furthermore, students felt that the game helped them enforce basic coding concepts, and that regardless of the mode the game was played in, it would be valuable for first-year computer science students.
Thank you for listening to our presentation. If you would like to know more about our research, visit our project website. If you have any questions, send us an email and we would be happy to answer.